Hey everybody, today's lesson from Unit 2.1 will cover perpendicular bisectors. So the first thing we need to do is review how to construct a perpendicular bisector of a line segment. So for today's lesson you need not only your pencil or pen, but you need a compass or other construction tool and a straight edge. So first, in this space underneath number 1, let's draw a line segment. And don't make it too long. And let's go ahead and label that line segment AB. Okay, so obviously I'm not using a ruler. I can't use a ruler on the iPad to create a perfectly straight line segment, so mine will look a little bit less perfect than yours will. Okay, next we're going to construct the perpendicular bisector of this line segment. So take your compass, put the compass point on point A, and then adjust your compass so it's open more than half the distance from A to B. All right, strike an arc using your compass above and below the line. Okay, that's going from point A. You make two little arcs, one above the line, one below the line. And then take your compass and put the point on point B. Keeping the same compass setting, strike arcs above and below so that they intersect your first two arcs. Okay, next, see those points of intersection where those arcs meet? You're going to take and line your ruler up with those 2 points and use your ruler and your pencil to make that line segment. And we're going to name a point on this line segment point C. And you can do it at that point of intersection, or you can do it anywhere on this blue line on that perpendicular bisector. By the way, we should show that this is a perpendicular bisector by marking this as a right angle. That proves it's perpendicular. The line segment in blue is perpendicular to AB. It also bisects line segment AB. So mark these two segments congruent to each other. Okay, next, I'd like you to take your ruler and actually connect point A to point C and connect point B to point C. And use your ruler to measure those two segments. Okay, in question 4, it says, what do you notice about AC and BC? And what you should find is that they're congruent to each other. If you measure them each with your ruler, either in centimeters or inches, you should find out that they're the same length. Okay, choose another point. This is step 5. Choose another point on that perpendicular bisector and label it point D. So I'm going to choose this point right here, label that D, and again use your ruler and connect A to D and connect B to D and measure those distances, and again you should find out that those segments are congruent. And this is going to lead us to our two theorems for today. So what we just proved is that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And this is called the perpendicular bisector theorem. Again, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Now the converse of the perpendicular bisector theorem is also true. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So again, the converse of the perpendicular bisector theorem says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So, using these two theorems, if we know in the first place that this segment is perpendicular to this given segment and it bisects it, then we would know that this distance is equal to this distance. And by the converse of the perpendicular bisector theorem, if we know that this point is equidistant from each of these 2 points, here and here, then we would know that this line segment is perpendicular to the other line segment, and then it bisects that line segment. Okay, let's practice some problems together. For the first 3, it just says that we have to tell whether the information in the diagram allows you to conclude that A, the point A, is on the perpendicular bisector BC. So take a look at number 1. Here's point A. and A is on this line segment. And we want to know if that line segment is perpendicular to BC and if it bisects BC. So take a look at the markings. It's definitely perpendicular to line segment BC, and it definitely bisects it. So the answer is yes. That one's pretty straightforward. You look for perpendicular, look for the little box for the right angle, you look for segments that are congruent. Number 2, it's not quite as obvious. So if I take a look at where point A is, and it's along this line segment, I would say yes, it's perpendicular to BC, okay? But I don't see markings that show that these two segments are congruent. So in this case, we're going to actually use the converse of the perpendicular bisector theorem. If you check out these other two line segments, HB and HC, do you see how they are congruent? Since they're congruent, we know that H is on the perpendicular bisector of BC, and that makes HA the perpendicular bisector of BC. So this one is yes as well. So again, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So we would be able to conclude that those two are congruent. Finally, in the third case, point A is right here, and we have this line segment that does bisect this line segment, okay? But it's not marked in as being perpendicular to them. So we'd have to say no in this case. There's no way for us to prove that these two angles, here and here, are congruent and right angles. Okay, we don't have enough information to prove the two triangles congruent, so we can't just assume it from the diagram. In our last two examples, we have to use our theorems, a perpendicular bisector theorem and its converse, in order to solve for x and then to find the length of AB. So this isn't a case where we just want to stop where we find x. We actually have to take it and plug it in to find the length of line segment AB. So number 4, if you check it out, this line segment is perpendicular to BC and it bisects it. So since A is on the perpendicular bisector of BC, then A has to be equally distant from the endpoints of the segment. So that means that AB is congruent to AC. So we're going to set 2x plus 19 equal to 5x plus 7, and then solve for x. So subtract 2x from both sides. We end up with 3x on this side, and go ahead and subtract 7 from both sides. So that's 0 on this side, and 19 minus 7 gives us 12 on this side. So since 12 is equal to 3x, take and divide by 3, we get x equals 4. Now remember, as I pointed out in the beginning, we have to find the length of line segment AB. So since AB is equal to 2x plus 19, AB will be equal to 2 times 4 plus 19. Or finally, AB is equal to 8 plus 19. Okay, one more step. AB is equal to 27. You can also check it by taking and plugging the 4 in for x for AC and making sure that that's equal to 27 as well, which it is. Okay, in our last example, if we check it out, we have point B on this line segment. It is perpendicular to AC. It bisects AC. So since B is on the perpendicular bisector of a segment, it's equidistant from the two endpoints of the segment. And that means that BA is congruent to BC. So we can set 6x plus 17 equal to 4x plus 25. So take and solve for x. Subtract 4x from both sides, and we end up with 2x on the left-hand side. So 2x plus 17 equals 25. Subtract 17 from both sides. That's going to give you 8 on this side. Let's scoot this up a little bit. So we would have 2x is equal to 8. And again, we end up with x equals 4. No, don't jump to the conclusion that x is always equal to 4 in these cases. It's just that we made up two problems where we have x equals 4. Okay, don't forget, we also have to find the length of line segment AB in this case, according to the directions. So come back in, and we're going to take and we're going to plug in 4 into this equation, 6x plus 17. So we need to do 6 times 4 plus 17. So AB is equal to 24 plus 17, or that's going to give us 41. And again, you can double check your work by plugging the 4 in for x on BC and making sure that that's equal to 41 as well. Okay, good luck on the CYU and your homework, and please ask if you have any trouble at all.